Do some more practice with the graphing. You'll see that this time we have a equal to -3. So we are going to change our ordered pairs and multiply y by -3. Write down the key points for our basic function graph, and then write down the points for our transformation and graph it below. Of course, our y-intercept has changed. We've multiplied our y values by -3. You've marked your highest and your lowest points on the y-axis, and then you've labeled the x-axis with 4 intervals on each side of the y-axis. So we see then that our our x-intercepts are going to be every second interval. There's not one at 0, but every second one. Now we have a piece of the wave. We can finish the wave. We know we have to go above 0, back down to 0, and then below 0. Same thing on the other side. So instead of going from -1 to +1, we have a range from -3 to +3. Our domain is still the same. And the y-intercept at 0, -3. Find the key points for our basic function, y equals sine of x, and then graph the transformation. You can list your key points here. So notice that this time our y-intercept didn't change, because when I multiply 0 by 1/2, it's still 1/2. We still, however, have our x-intercepts at every second interval. And this time at pi by 2, we're going to go down because we were multiplying by -1/2. As soon as we have a piece of that wave, we can continue it by going above and below the x-axis. You can fill in the domain and range here. Our domain, still the set of all real numbers, and the range, -1/2 to +1/2. So you should remember this from week 3 when we were doing our graphing transformations for the first time. But this time a is specifically the amplitude of the function. And if a is greater than 1, we have a vertical stretch. If the absolute value of a is greater than 1, and if the absolute value of a is a fraction between 0 and 1, we have a vertical compression.